You won't believe what's hiding inside a black hole, something far stranger than we ever imagined. Black holes are one of the universe's biggest mysteries. We know they suck in everything around them, even light, but have you ever wondered what happens to everything inside? Is it just gone? Or is there something we're missing? The answer to this question could completely flip our understanding of space, time, and reality. And today, we're going to dive into the deepest, darkest corners of black holes to explore the wildest theories about what might really be inside. For decades, scientists have wrestled with the enigma of black holes. From Einstein to Hawking, some of the greatest minds have tried to figure out what happens inside one of these cosmic monsters. When a star collapses and forms a black hole, it creates a gravitational field so strong that nothing, not even light, can escape. But here's the real puzzle. Does everything that falls into a black hole just vanish? Or does it get stored in some mysterious way we can't fully understand yet? If black holes are just cosmic garbage disposals, where does all the stuff go? Does it get crushed into nothingness? Or could black holes be gateways to something even stranger, like other dimensions or alternate universes? We're talking about theories that sound like they came straight out of science fiction, but they're rooted in real science, and some of the answers might be closer than you think. Before we get to the mind-bending theories, let's break down the basics. Black holes are formed when massive stars, at least 10 to 20 times bigger than our sun, reach the end of their life cycles. When these stars run out of fuel, they collapse under their own gravity. This collapse is so extreme that the star's core becomes incredibly dense, creating what's called a singularity. A singularity is a point in space where gravity becomes infinite and the laws of physics as we know them break down completely. Surrounding the singularity is the event horizon, the boundary beyond which nothing can escape. Once you cross the event horizon, you're gone. At least from the perspective of our universe, the event horizon is like the ultimate do not cross line in space. Everything that gets sucked in, a star, a planet, even light, disappears behind it, never to be seen again. But here's the kicker. Scientists have no idea what happens beyond the event horizon. That's where things get really weird. One of the biggest mysteries about black holes is what happens to the information that falls into them. This is called the black hole information paradox, and it's been driving physicists nuts for decades. According to the laws of quantum mechanics, information can't be destroyed. But according to general relativity, black holes destroy everything that crosses the event horizon. So, which is it? Let's break this down in simpler terms. Imagine you throw a book into a black hole. According to general relativity, that book and all the information inside it is gone forever. But quantum mechanics says, hold up, you can't just erase information like that. Every particle in the universe contains information about its position, speed, and energy, for example. In theory, that information has to go somewhere. This paradox has led scientists to some pretty wild ideas. One of the leading theories is that black holes don't actually destroy information, they just store it in a way we don't yet understand. And this is where things get really interesting. One of the craziest ideas to come out of the black hole information paradox is the holographic principle. This theory suggests that everything inside a black hole, the entire three-dimensional contents, could be described by information stored on its two-dimensional surface, the event horizon. In other words, everything inside the black hole is encoded on the event horizon, like a hologram. Think about it like this. Imagine you have a computer hard drive that can store every single detail of an entire three-dimensional world on a flat, two-dimensional surface. That's kind of what the holographic principle is suggesting. The idea was first proposed in the 1990s by physicists Gerard R. Hooft and Leonard Susskind, and it's become one of the most mind-blowing concepts in modern physics. If this theory is correct, then black holes might not be as destructive as we think. Instead, they could be cosmic hard drives, storing all the information of everything that falls into them on their surface. But here's where things get even weirder. Some physicists think that this principle doesn't just apply to black holes, it could apply to the entire universe. Yep, you heard that right. According to some interpretations of the holographic principle, everything we see, Everything around us, our entire universe, might be a projection of information stored on a two-dimensional surface. This idea is still highly speculative, but if it's true, it would completely change the way we understand reality. Now, let's take things to the next level. Some scientists believe that black holes might be more than just storage units for cosmic information. They could be gateways to other parts of the universe, or even to other universes entirely. This theory is based on the idea of wormholes. In simple terms, a wormhole is a tunnel through space-time that connects two distant points in the universe. Think of it like a shortcut through space. If you could travel through a wormhole, you could potentially move from one part of the universe to another instantaneously. Here's where black holes come into the picture. Some physicists think that the inside of a black hole could be the entrance to a wormhole. If this is true, then black holes wouldn't be the end of the road. They'd be a doorway to something else, maybe even to another universe. This theory is still highly speculative, and we don't have any direct evidence of wormholes yet, but it's a tantalizing idea, especially when you consider that black holes and wormholes are both solutions to Einstein's equations of general relativity. They both involve incredibly strong gravitational fields, and they both distort space-time in extreme ways. It's not a huge leap to think they might be connected. Let's go deeper into the black hole, right to the singularity, the point at the center where gravity becomes infinite. This is where things get really strange, because the singularity is a place where the laws of physics as we know them just stop working. In the rest of the universe, we use two main theories to describe how things work: general relativity, which explains how gravity works, and quantum mechanics, which explains how tiny particles behave. But here's the problem. These two theories don't get along, especially inside a black hole. In most places in the universe, general relativity and quantum mechanics coexist just fine. But at the singularity, gravity is so intense that it overwhelms quantum mechanics. The result? A total breakdown of our understanding of reality. This is one of the biggest unsolved problems in physics. Scientists have been trying to develop a theory that combines general relativity and quantum mechanics into one unified theory, often called quantum gravity. If we can figure out how these two theories fit together, we might finally understand what's really happening inside a black hole. One of the most promising candidates for a theory of quantum gravity is string theory, which suggests that the fundamental building blocks of the universe aren't particles, but tiny, vibrating strings of energy. String theory also predicts the existence of extra dimensions, up to 11 of them in fact. Could these extra dimensions be hidden inside black holes? Some scientists think it's possible. Okay, now we're getting into seriously mind-bending territory. Believe it or not, some physicists think that black holes could actually function as time machines. Yes, you heard that right. Time machines. Here's how it works. According to Einstein's theory of general relativity, massive objects like black holes warp space-time around them. This warping effect is what creates gravity. But if you warp space-time enough, you could theoretically create a closed time-like curve, which is a fancy way of saying a path through space-time that loops back on itself. In other words, you could travel through a black hole and end up in the past. Now, before you get too excited, there's a huge catch. Most physicists agree that even if black holes could theoretically allow for time travel, it would be incredibly dangerous and probably impossible for a human to survive the journey. The intense gravitational forces would stretch and compress anything that tried to enter the black hole, a process known as spaghettification. Yep, that's a real term. You'd literally be stretched into a long, thin strand of matter, like a piece of spaghetti. But the idea that black holes could bend time is fascinating. It raises all sorts of questions about the nature of time itself. Is time linear, or is it more like a loop? Could black holes hold the key to understanding how time works on a fundamental level? Remember how we talked about the event horizon, the point of no return? Well, some physicists think there could be something even stranger happening at the event horizon. A firewall. This theory, known as the black hole firewall paradox, suggests that instead of a smooth crossing, anything that falls into a black hole would hit a wall of high-energy particles at the event horizon and be incinerated instantly. This idea came out of an attempt to solve the black hole information paradox, but it's still highly controversial. If firewalls do exist, they would completely change our understanding of black holes. Instead of smoothly falling into the singularity, anything that crosses the event horizon would be vaporized. This would mean that black holes aren't just cosmic garbage disposals, they're more like cosmic crematoriums. The deeper we go into the mysteries of black holes, the more we realize that these cosmic monsters are far stranger than we ever imagined. Whether they're storing information, leading to other universes, or functioning as time machines, black holes challenge everything we thought we knew about the universe. But here's the most exciting part. We're just getting started. Thanks to new discoveries in quantum mechanics, string theory, and even space exploration, we're getting closer to unlocking the secrets of black holes. And when we do, the answers could completely revolutionize our understanding of space, time, and reality itself. So, what's actually inside a black hole? The truth is, we don't know for sure yet. But one thing's for sure, black holes are not just voids of nothingness. They could be storing information, connecting us to other dimensions, or even bending time. The more we learn about black holes, the more we realize how little we know about the universe. As scientists continue to push the boundaries of our understanding, one day we might finally get a glimpse of what's really inside a black hole. And when that day comes, it could change everything. Don't miss out on our next cosmic adventure. Hit subscribe and keep exploring the universe with us.